Hello everyone, welcome back. So in this video, we are going to understand a very important question because there is a lot of concept behind this problem. Okay, and many approaches you can try. Okay, very first, let's understand what the question is saying. That the question is saying that minimum operations to make the integer 0. Okay, this is problem number 2749 from the Leetcode, and the question is saying that you are given two integers, num1 and num2. The two integers we have like x and y, we can say that, and in operations you can choose integers I in the range 0 to 60 and subtract 2 to the power I plus num2 from num1 and return the integer denoting the minimum number of operations needed to make num1 equal to 0. If it is impossible, make num1 equal to 0, return -1. Okay, this is what we have given in the example. You can go through. If you come to the constraint is saying that num can be greater than equal to 1 and can be 10 to the power 9. Okay, and this is what we have given for the num2. It can be 10 to the power -9 because the possibility for the num1 could be 10 to the power 9, and that is why it start with the same negative values, because if let's suppose the biggest value we have for the num1, it can be -9, so the value will become 0, like that we can say. But the lot of concept is different. Try to understand from here. Okay, very first, let's understand what we have given. Right, we know that we have given two things, num1 and num2, we can say that, not num. So this is two integers we have. Okay, and it is also saying the range is where we can say, let's suppose it is from, we can say 0 and 60. This is the bound, right? So the if we want to choose an integer, right, let's suppose any integer is there, so this is called talking about the integer I. So we'll say, so integer I should be between what, 0 to 60. So when we choose an integer in an operation, right, we need to choose between 0 to 60. That is fine. That is what the question is saying. That now it is saying we have to return the integers, right? What we have to return the integer, it is talking about the minimum number of operations. Okay, we have to return minimum number of operations, what, to make nums equal to 0. Means it is talking about if we want nums equal to nums1 equal to 0, if it is become nums equal to 0, means how many operations it required. So give the count of the operations that you performed. Understand, that we need to do. If it is not able to do this job, return -1. I hope you understand. So there are some technical terms see there mathematically that we should understand before going further. Okay, very first, let's suppose what is the idea behind this, right? So if we perform, let's suppose how many k operations. Okay, so there are some k operations are there that if we want to perform, right, so there will be some indices. Let's suppose I'm talking about between this range. So the indices between this range can be, let's suppose I1, I2, and there can be many other I indices. We can say from 1 to k we can take, right? So this is what we can say if we want to perform how many operations, k operations with some indices, and these are the indices that is possible. These are the possible indices, we can say, that can be performed within these operations, right? Means if you want to perform the key operations with these are the indices, so what is the total subtracted, we can say. You forget about me, let me forget me, forgive me, sorry, forgive me if the spellings are different. Okay, so we'll talk about, let's suppose total subtracted total subtracted from num1, not nums1, this is num1. Why I'm saying nums1 again. Okay, num1. So if we find the total subtracted from num1, so if we say the total subtracted from num1 is what, we can say, yeah, there is a num2. If we'll do 2 to over I. Okay, because indices start at where, at I1. We'll say I1. Similarly, we'll do plus for all the indices. We'll say num2 plus 2 to the power I2. We'll do plus and we'll go so on till we'll do plus num2 plus 2 to the power I k. Can we say that? So this is what we can do for the total if we want to find the total subtracted. So if we want to find the total subtracted, this is what we can say. So can we say that if we'll do the sum of all these, we can say here, let's suppose num2 we have, right? So we are taking for how many? Total k, right? We are talking k operations. So if we talk about the total k operations, we need to multiply by k. So we'll say k into, means we want the k operations. So in the total k operations, right, we want to go with all these indices. So we'll say multiply k into num2, we can say, plus we can say about these are the plus, and we will calculate for this part. We know that this is how many times? K times. So that we have said k into this part. Now let's talk about this part. We have to do the sum. So if we want to do the sum, can we say that plus you have to multiply, right? Or you can take the sum. Let's take by the sum. Yeah, it will be sum actually. 2 to power 1 plus 2 to power I2 and 2 to power I, what you call, we'll take more, right, till k. Yeah, this is what we again say. So if we will say k into num1, we can say we'll do the sum, all the sum, and we can find 2 to power I1 plus 2 to power I2. There will be more elements will be there, plus 2 to power I k. That is what we have here. We can say this is what we will get. Means if we want the total sum, if we want to perform in the total sum to make 0, so the indices that we are going to use is I1, I2 and Ik. We can say that. So total subtracted from num1 can be num2 plus 2 to the power I1, num2 plus 2 to the power I2, and so on till Ik. And if we'll find the total, right, mathematically, k into num1 plus 2 to the power, like this, we can say that. Okay, I think we can also go further. Let's try to go. So if we will, let me remove. Okay, so very first, we were talking about what? 2 to power, we have to multiply, right? How many? K into 2 to power I, right? What was there? I forget. Let me go back. Okay, so it was k into num2. Yeah, I forget that. K into num2 plus it was 2 to power I1 plus 2 to power I2 plus 2 to power Ik, and there was many elements for there. Okay, for now we can say. So can we say about this part that if we'll say there can be many possibilities, right? Okay, so very first, if we'll say we have num1, right? If we'll do num1 minus k into num2, num1 minus k into num2 is, let's suppose we have the sum s, right? This s is the sum of exactly k powers, right? So that we have seen. Okay, so powers maybe it will repeat, or some we can say that. Let's suppose we'll say k is nothing but we have num1 minus k into num2, right? Where x will be greater than equal to 0, so that it will not repeat for what? Negative values. So let's try to understand. Okay, very first I'm saying if num1 minus k into num2, and which is coming is equal to s, I'm talking. Okay, where s must be sum of exactly k powers of 2, right? And powers may repeat. Okay, so we'll say let's talk about x. Let take x which is equal to what, num1 minus k into num2. Then we'll say it should be x must be greater than equal to 0, so we can't represent a negative sum of power of 2, that we can say. Okay, so we don't want to represent a negative sum of positive power of 2, right, as a less than value. So we'll say it should be always greater than equal to 0. No need to write it, but we should understand it. Okay, so we'll say like this. Now let's suppose if we will have give me 1 second, we will take the pop count. Okay, we will take the pop count x, and this pop count x is the number of 1s, right? We can say number of 1s. Okay, in binary representation. Okay, so the pop count is the minimum number of power of 2 which is required to form what, x. I hope you understand, right, what I'm saying. I will take a function, we'll say pop count, that will take the input x, right? And you know what is x, right? We have already defined. So if we will take, this is also let, this is also let. Give me 1 second, sorry. So pop count x is the number of 1s, right, in the binary representation of x, right? It's a binary representation, right? We'll say it's a binary representation of what, x, we can say. Okay, of this part, and that is x. So the pop count is the minimum number of 2 required to form x. That is fine. So we must have pop count x should be less than equal to k. Am I right or not? I'm right? Because I said very first I talk about what, the s. S must be the sum of exactly how many powers, k powers of 2. And we have also talked that we assume that we have x which is num1 minus k into num2, right? So we also talk about x should be 0, greater than equal to 0, right? Because we don't want to represent the negative value, right, of some powers, we can say, of 2, we can say. Because if this power of 2 is something is coming, it should not be the negative value. Okay, it should not give the negative sum. Okay, then we talk about the pop count, and this pop count must be a number of 1s, right, in the binary representation of the given x that we have to, not given x, of the x, we can say. So the pop count is the minimum number of powers of 2 required to form the x. Okay, so we must need the pop count should be always greater than equal to k. It means what, we also must have the k should be less than equal to x. Okay, so because the smallest power is what, we talk about 1, 2 to power I 1. So we'll say the smallest power start between 0 to 60, and so we'll say the smallest power, if we'll take 0, it will still come what, 1. So the smallest power is nothing but 1. Okay, so the sum of k powers of 2 is at least what, at least k. Understand? If the sum of k powers we will take, it should be at least k. So if we'll rewrite, I don't have a space here to write, so we'll say, let me clean it. If you want, I'll show you later. Okay, so we can say for a candidate, also for a candidate k, what we should check, we should check x equal to num1 minus k into num2, can we say, where we'll say if the x is greater than equal to 0 and the pop count that we have talked about, let's call x pop count of x, it should be less than equal to k, which is less than equal to x, we can say, right? And these are feasible. Okay, is it feasible or not? Because say, let's suppose we want to find what the smallest feasible k, right? If we want to find the smallest feasible k, because I is bounded by what, 60, right? In the statement that we have seen, means if we trying k, right, k could be go up to what, 60. So the maximum we can take is this in the safe limit is 61, right? And it should be enough. Okay, that is why the inducer was saying k should be less than equal to x, and that is why I have written here k should be less than equal to x. That works, right? So you always split the values. Let me tell you how. Let me clean it. Try to think, you will understand. Okay, so because I is, we talk about, it is bounded by what, 60, right? So it should be within the 60 that we have talked about already. Okay, now let's talk about why what I was talking about, k should be less than equal to k, right? Yeah, so why k is less than equal to x works, we can say, that we should understand. Because you always split a power of 2, right? 2 to power t, we can say. Okay, into what, into 2 to the power, we can say, t minus 1, can we say that, plus 2 to power t minus 1, we can say, like that we can say. And it could be repeatedly, right? It can go and so on. So it should be repeatedly to increase the count of summand, we can say, by 1 each split, right? So any k, so for any k, we can say, so for any k, what we can say, between so for any k between pop count x and x is achievable, or say it is feasible. That is why we say it is feasible. I hope you understand. So algorithm very simple. What you need to do, you will take let's suppose for k 1 to 60. Okay, so that will work for you, because very first, if you talk about you are going from 0 to 60, you should check 0, right? So if you take the num1 is equal to 0, means you have to compute what, x is num1 minus k into num2, right? Then if you will say, if x is less than 0, you will skip, you will not do anything. Then what you should do, you should check, let you have a pc count, you can get from what, long dot bit count, right? And you will pass the x, you will get the pc count, right? Means pop count. Then you will check, let's suppose, let me clean, you will say the pc count is less than equal to x and k is less than equal to x, means return k, correct? If not, return -1, that you can do, and it will work. In both cases, we loop 61 times, right? And do the pop count. Okay, and that will work in O of 1 times, we can say. Okay, and this is time complexity, we'll talk. So this is also constant, and the space is coming off 1 times. So that will work fine. Okay, but I will talk about this approach later, means in this video itself, but I'll go with the very simple steps so you can understand. Very first, try to understand. Okay, very first, what we need to do. So we'll need to do means we will try all the possible operations, count k, and we only need to try up to 60 because the power of 2 are limited from 2 to the power 0 to 2 to the power 60. Okay, so we'll say, okay, my k will be from 1 to 60. Okay, so we'll compute the remaining value after the subtracting these times, right? 2 to nums 2 plus 2 into plus 2 to the power I, and in k times we can say. So the formula is num1 minus k into num2 that we have seen, and this is nothing but the sum of power of k of 2. So we'll find like this, we'll get the target, we'll find the target, and the next step we'll check if the target is negative, we'll skip this k, and because the power of 2 is always greater than equal to 0, so we'll say this is our sum, right? If it is less than 0, target sum less than 0, we'll continue, will not do anything, we'll skip it. Then in the next step we'll count how many power of 2 are we required, right? We can say minimum. So this is exactly the number of 1s in the binary representation, and we know how to do that. Long dot bit count we'll pass our count, we'll get the bit. Okay, so in the next step we have to check the feasibility for the condition. At least the bits operations are needed to cover all 1 bits. So at most target operations are feasible since we can use 2 to the power 0 equal to 1 repeatedly. So the valid bits are less than equal to k and should be less than equal to the target sum. So we'll say bits should be less than k and k should be less than equal to the target sum, and so we will find the smallest valid k and will return immediately k, right? I hope you understand. So long we will use for the intermediate arithmetic to avoid the what the overflow. Okay, and this will give you the long dot bit count x, will give you the pop count x efficiently, and that is called we'll say as a bits. Okay, so that is what I have, right? You can do also you can use the very first. Okay, so if you try this, so it will work for all the solutions. Okay, I was talking about another thing. Let's talk about what if I'll comment this piece of code. Okay, so what we can do very first, let's talk about if we have num1 and num1 is equal to 0. Okay, here we'll return 0, right? And so when num1 equal to 0 means we want to we know that already have 0, we don't need to do anything. Okay, then we'll make a condition like this. We have use that we need to go for all the loops, right? We can say this will is also not different, too much different, but some representation that I have talked like that it will work. Okay, so for k equal to 1, right, we have to k1 to less than 60, we need to find, let's suppose, called the target that we have seen here. Like that we will find our own value. Okay, and that we can give here. Okay, and similarly you will find the PC count, right? That is your bits, right? And similarly we check the other values. Okay, so that will work exactly that we have seen here like this. So you can make the conditions itself here, and that will work for you also. Okay, so I hope you understand it, and if you have any doubt, let me know in the comment section. I will not go in the deep, right? So I'll suggest please try by your own and let me know in the comment section that you want to understand. Okay, Video is already too much big, so that's all. And if you have any doubt, please ping me in the comment box. We'll go through. Thank you guys. Thank you for watching this video.